Alright guys, so this is the start of chapter 10, and chapter 10 is our circles chapter, and by the time we're done with this chapter, you're going to know so much more about circles than you ever dreamed were true and that you ever wanted to know. Okay, there's an abundance amount of information in this chapter. The first part of it is um, a lot of vocab and then angle measures and things like that. The second part of it, we get more into formulas and side links and things like that. But just to get our brains working, let's go ahead and do these three problems. So on number one, forget for now there's this circle, okay, and just focus on this right triangle. Okay, we know it's a right triangle because here's the box in the corner. And we know for any right triangle, we can use the Pythagorean theorem if we know two sides and want to find the third side. Okay, so r squared plus 12 squared equals 13 squared. Well, 12 squared is just 144. 13 squared is 169. Do some simple algebra here. You get r squared equals 25. To undo a square, you square root. So we would get the radius here is 5. Alright, on number 2, we know that the radius, both of these radii, have to be the same length. And once again, we're looking at it as a right triangle, so r squared plus r squared equals 18 squared. And so then if we work this out, r squared plus r squared equals 18 squared is 324. Okay, so this is 2r squared equals 324. Divided by 2, divided by 2. I'd get r squared equals 162. Undo a square root, or to undo a square, you do a square root. So we would need to break 162 down. Okay, 162, let's do 3 first. 54 times. 3 goes into 54, 18 times. 3 goes into 18 6 times. 3 goes into 6 twice. 2 goes into 2 once. When we get to 1, we're done. So we have a pair of 3's, a leftover 2. So 3 times 3 is 9. Our leftovers go in the fridge. So our radius here is 9 square root of 2. Alright, let's look at number 3 here. Okay, so number 3, same thing, r squared plus 8 squared equals, now this might confuse some of you, this is our hypotenuse. Okay, and this whole thing here can be found by taking r plus 4. So equals r plus 4 squared. Okay, now remember, r plus 4 squared does not equal to r squared plus 4 squared. Okay, no, 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 don't do it. Okay, r plus 4 squared equals r plus 4 times r plus 4. Okay, so r squared plus 64 equals r plus 4 times r plus 4. Alright, so the left side of the equation stays the same. Now we will need to FOIL this. Okay, so when you FOIL it through, you get r squared plus 8r plus 16. Okay, minus r squared, minus r squared. I get 64 equals 8r minus 6, 8r plus 16. Minus 16, minus 16. I get 48 equals 8r. Divided by 8, r is 6. Alright, so let's go over this first page of vocab. Okay, so first is the definition of a circle. The circle is a collection of all points, and when I say all, there is an infinite number. That in a plane that are equidistant from a given point, and that given point is the center of the circle. Okay, so if I have a point here, and I want every point on this plane that is, I don't know, 2 inches away from here, 2 centimeters or whatever, it'd be this point, and this point, and this point, and there'd be an infinite number all the way around. Okay, and if you get all of those points together, they would make a perfect circle. All right, so our next vocabulary word is the center of the circle. Okay, so the center of the circle is just the fixed point. When I mean fixed, it doesn't move, it's set in here, from which all points that lie in a circle are equidistant. All right, so our next vocab word is a radius, and hopefully you guys know what this is. But a radius is a segment in the circle in which one endpoint lies on the circle while the other lies on the center. Okay, so I'm going to go to this vocab diagram. So if one point is on the circle and another one's the center, if I connect these dots, this would be a radius. All right, so the next vocab word, hopefully you know this too, is the diameter. So the diameter is a segment in a circle and with both endpoints lie on the circle, but it must pass through the center. So it also contains the center point. All right, so if I were to draw diameter on here, one of the endpoints is here. It's going to go all the way through the circle, pass through the center, continue on, and here's the other endpoint. So this would be a diameter. And as you remember, the diameter is twice the radius, or the radius is half the length of the diameter. All right, so let's go to some more vocab, and these vocab I'm guessing will probably not be as familiar. Okay, so a chord of a circle is a segment and with both endpoints are on the circle. Okay, so if I go to my diagram, a chord would be something like here to here. This would be a chord. Okay, so a diameter is an extremely long chord because both endpoints are on the circle, but it's special because it passes through the center. A chord usually is a lot shorter than the diameter, and does not pass through the center typically. All right, so a secant would be a line that intersects a circle at 2 points. Okay, so a secant is very similar to a chord. Okay, the difference between a secant and a chord would be a secant goes through the circle and it is a line and it keeps going. So this would be a secant. Okay, a chord stops on both sides of the circle. A secant keeps going through. Okay, the next one is a tangent of a circle. Now don't confuse this tangent with like sine, cosine, tangent. There's no relation here. It just happens to be the same word. But a tangent of a circle is a line in the plane of a circle that intersects the circle at exactly 1 point. Okay, some of you are thinking, how does that happen? All right, so if we go to our diagram to draw a point of tangent, I'll try to draw this as straight as I can, but this is supposed to be a straight line. It would start outside of the circle, okay, and it would just touch it, but keep going. It never goes into the circle, okay, but it just touches it right here. And once again, this line is supposed to be straight, okay? So this is called a tangent. Okay, now the point of tangency is simply the point at which a tangent, oh my gosh, a tangent line sorry guys, this is being glitchy on me, intersects a circle. So when I go back here, this point right here, this would be the point of tangency. All right, so let's put some of these vocab words into action. Let's look at example 1A. All right, so on 1A it says ray DE. Okay, so if I look at this, so from here goes through DE and keeps going. Okay, now if I could draw a straight line in the previous diagram, this would be what a tangent looks like. Notice it never goes into the circle, but it only touches the circle at this one point right here. Okay, so it would be a tangent. All right, the next one is AC. Now notice there's no arrows on here. So AC is just talking about this segment. So from A to C, and that's it. Okay, so hopefully you would know that this is a radius. All right, so let's look at C. Let's look at AE. And if you notice, I know it's really hard to see, this does have an arrow on both sides. So AE is this line here that goes on forever and ever and ever. Okay, this would be a secant. Okay, now, last but not least, AB, so A to B, this would be a diameter. It would also be a chord, but obviously diameter would be a much more descriptive and accurate label for this. All right, so here's example 1B. Now I want you to go ahead and try to do these on your own. Just make sure you look at your vocab and your definitions, and then we'll go over them. All right, so let's go over these now. The first one, what's the word that describes segment AG? And notice this is a segment here. So we start at A, we end at G. So only what's highlighted here, and that would be a chord. If I would have had line AG, means it keeps going on both sides, that would make it a secant. Okay, that's the difference between a secant and a chord. All right, what is the name of the circle? You probably didn't know this. It wasn't fair for me to ask you this because we hadn't gone over it yet. It is circle C. Now, circles are named according to their center. Okay, so it's always the center of the circle. And then we say circle C, so circle looks like this, C. The point of tangency, you should have known that. It's the point in which a tangent line meets the circle, so that would be point B. And then a tangent would be DE, and I put a line over it. You could have put DB with a line over it, BD, ED, all these different ones. And then a tangent segment, I just use the same thing, but this time with a segment.